Namaste and welcome to GAP. Today we are going to discuss about the James Webb Space Telescope. In the end we will tell you how far James Webb Space Telescope, difference between James Webb Space Telescope and Hubble Space Telescope, and also we will understand about the various images captured by James Webb Space Telescope. So without further delay, as always let's begin our exciting and informational journey. Firstly, let's discuss about the James Webb Space Telescope. The James Webb Space Telescope, JWST, is the largest space telescope made to conduct infrared astronomy. Its high-resolution and high-sensitivity instruments allow it to view objects too old, distant, or unclear for the Hubble Space Telescope. The James Webb Space Telescope, JWST, is designed to be the most powerful space telescope ever built, with the primary goal of studying distant celestial objects and events to expand our understanding of the universe. The James Webb Space Telescope, JWST, is an ambitious project led by NASA in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA. It is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini and Apollo programs. Now, we will understand about the organization involved in this project. NASA is the primary agency responsible for the overall management of the JWST project. It oversees the development, construction, and deployment of the telescope. NASA also provides the launch vehicle and mission control. The JWST was launched on 25 December 2021 on an Ariane 5 rocket from Cora, French Guiana. The NASA Goddard Space Flight Center, JSFC, in Maryland managed telescope development, while the Space Telescope Science Institute in Baltimore on the Homewood campus of Johns Hopkins University currently operates Webb. ESA, European Space Agency ESA, is a significant partner in the JWST project. It has contributed one of the main scientific instruments on board, the Near-Infrared Spectrograph, NIRSpec, and also some other components. ESA plays a crucial role in the development and scientific usage of the telescope. CSA, Canadian Space Agency. The Canadian Space Agency has contributed the Fine Guidance Sensor Near-Infrared Imager and Slitless Spectrograph, FGS NIRIS, another one of JWST's scientific instruments. It is responsible for the design and operation of this instrument. Northrop Grumman, the aerospace company Northrop Grumman, was the primary contractor responsible for building the JWST spacecraft and its sunshield. They were in charge of integrating all the components and testing the telescope before launch. The JWST industry team, led by Northrop Grumman Corporation, has won the prestigious National Aeronautic Association, NA, Robert J. Collier Trophy for revolutionizing the field of astrophysics with the team's pioneering design and exceptional performance of NASA's JWST. What are the key features of JWST? Purpose. The main scientific objectives of the JWST include observing the first galaxies that formed in the early universe, studying the birth of stars and planetary systems, and investigating the properties of exoplanets, planets outside our solar system, including their potential habitability. Now, the mission goals are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, to study galaxy formation and evolution, to understand star formation and planet formation, to study planetary systems and the origins of life. These goals can be accomplished more effectively by observation in near-infrared light rather than light in the visible part of the spectrum. For this reason, JWST's instruments will not measure visible or ultraviolet light like the Hubble telescope, but will have a much greater capacity to perform infrared astronomy. Observing range. JWST will operate in the infrared spectrum, covering wavelengths longer than those observable by the Hubble Space Telescope. This capability will allow it to peer through cosmic dust clouds and study objects that are obscured in visible light. Orbit. Sun-Earth L2 point. The JWST is positioned at the second Lagrange point, L2, located approximately 1.5 million kilometers, about 930,000 miles, from Earth. At this point, the gravitational forces of the Earth and the Sun balance out, allowing the telescope to maintain a stable position with respect to the Earth and the Sun. Components. The JWST is equipped with a 6.5 meter, 21.3 foot segmented primary mirror, which is much larger than the Hubble Space Telescope's mirror. The larger mirror allows jwst to gather more light and achieve higher resolution. It also has 4 scientific instruments on board: the near-infrared camera, NIR-CAM, near-infrared spectrograph, NIR-SPEC, mid-infrared instrument, MIRI, and the fine guidance sensor near-infrared imager and slitless spectrograph, FGS NIRIS. How far JWST can see? The James Webb Space Telescope, JWST, is designed to have an extraordinary observational range, allowing it to see incredibly distant objects in the universe. Its advanced capabilities and position at the second Lagrange point, L2, enable it to peer deeper into space than any previous space telescope. One of JWST's main scientific objectives is to observe the early universe, particularly the first galaxies that formed after the Big Bang. With its infrared instruments, it can peer through cosmic dust and study objects that are obscured in visible light. By observing these early galaxies, JWST can effectively see back in time, providing valuable insights into the universe's early history. Now, it's time to know about JWST team. More than 1,000 people in more than 17 countries developed the James Webb Space Telescope. Shown here are team members in front of the JWST full-scale model at the Goddard Space Flight Center in Greenbelt, Maryland. When is the first images captured by JWST released? On July 2022, President Joe Biden released the first full-color image from NASA's James Webb Space Telescope during a public event at the White House in Washington. This first image showcases the powerful capabilities of the Webb mission. Webb's first full-color image reveals thousands of galaxies, including the faintest objects ever observed in the infrared, and was created using just 12.5 hours of observing time on one of the telescope's 4 instruments. First image, this landscape of mountains and valleys speckled with glittering stars is actually the edge of a nearby, young, star-forming region called NGC 3324 in the Carina Nebula. Captured in infrared light by NASA's new James Webb Space Telescope, this image reveals for the first time previously invisible areas of star birth. Second image, the dimmer star at the center of this scene has been sending out rings of gas and dust for thousands of years in all directions, and NASA's James Webb Space Telescope has revealed for the first time that this star is cloaked in dust. 2 cameras aboard Webb captured the latest image of this planetary nebula, catalogued as NGC 3132 and known informally as the Southern Ring Nebula. It is approximately 2,500 light-years away. Third image, Stephan's Quintet, a visual grouping of 5 galaxies, is best known for being prominently featured in the holiday classic film, It's a Wonderful Life. Today, NASA's James Webb Space Telescope reveals Stephan's Quintet in a new light. This enormous mosaic is Webb's largest image to date, covering about 1/5 of the Moon's diameter. It contains over 150 million pixels and is constructed from almost 1,000 separate image files. Fourth image, within the orange-white splotch at the center of this image are 2 actively forming stars. The 2 stars are buried deep in a disk of gas and dust that feeds their growth. Over thousands of years, the pair repeatedly gobbled up, then spat out the material around them, producing those fiery orange lobes. Fifth image, a gray spiral galaxy with a bright white, circular core. Its spiral arms resemble spider web threads. Red dots are scattered throughout the black background. This mid-infrared image of NGC 1433 was captured by Webb's MIRI. Now, we will understand about the key differences between James Webb and Hubble. James Webb was launched in 2021. Lifetime of 10 years. Mirror size is of 6.5 m. Mass is of 6,200 kilograms. It operates under -230 degrees Celsius temperature. Distance from Earth is about 1.5 million km. And it works on wavelengths of near-infrared and mid-infrared. Hubble was launched in 1990. Lifetime of 31 years. Mirror size is of 2.4 m. Mass is of 12,200 kilograms. It operates under 20 degrees Celsius temperature. Distance from Earth is about 570 kilometers. And it works on wavelengths of ultraviolet, visible parts of infrared. Here are the few images which clearly show us about the quality of images taken by both Hubble and James Webb. We can clearly see that the images taken by James Webb are more refined and of high quality. Due to its revolutionary technology, and advanced position at L to the James Webb Space Telescope is expected to expand our understanding of the universe significantly and unlock new discoveries about its history and evolution. Conclusion: the JWST is expected to transform our understanding of the cosmos, providing valuable data that could reshape our knowledge of the early universe, star formation, exoplanets, and much more. As a successor to the Hubble Space Telescope, it represents a significant leap forward in space observation capabilities. So, this brings to the end of today's session. I hope I have been able to make you understand about the James Webb Space Telescope. If you have any questions for us, you can comment in the comment section or email us. We would be happy to help. Thank you for your time. Stay safe and stay happy.